Now let's take a look at lighting in Blender. Lighting not only illuminates the scene, but it also can add mood and drama to your scene. So lighting is very important. So we're going to start off by taking a look at a very simple light called the point light and then move on from there. So in this scene, I have a simple cup and saucer, and it has no lights in the scene. If I hit F12 to render, you'll see that, well, you won't see much actually because there is no light in the scene. It renders black. So we can fix this, of course, by adding a light. So I'm going to go into my add menu, and lights in Blender are called lamps. So we have 5 different types of lamps. We have point lamps, sun, spot, hemi, and area lamps. And I'm going to select the point lamp. Now, when this comes up, you'll see that I have it selected. And if I want to see a rough approximation of the light, I can turn on textured mode. And you'll see that the light actually can be seen in my viewport. So if I move this light up, you'll see how it affects the lighting in the scene. Now, this is a point light, which means it's kind of like the bare light bulb in the room. It generates energy in all directions. So with it directly above the cup, you see I'm not getting any shading on the side of the cup. So I need to move this. I'm going to move this in Y a little bit over here so I have a pretty nice illumination. Now, with this light at default, it may or may not be bright enough. Let me go ahead and do a quick render and we'll see what happens. And the scene actually looks a little bit dim. And part of this is because of the way default lights work in Blender. If I have this light selected, I can go over to my lighting panel, and this allows me to control all the different lights. For right now, let's just jump straight down to the fall off value. And this is by default set to inverse square, which is actually natural lighting. Real world lights fall off with the square of distance from the object. That's why things get dimmer the further you are from the light. But for this, let's go ahead and set this to something else. We're going to set this to constant. So this provides constant illumination. The light has no fall off and it illuminates everything evenly. So if I do a quick render, you'll see that I get a pretty decent render here. So with this, let's go ahead and take a look at some of these other parameters for this lamp. Along the top here, we have a selection list of all the different types of lamps. So I selected point lamp from the add menu, and that's what I got. But if I want to decide to change it, I can later. I can make it a sun, a spot, a hemi, or an area lamp. Now notice how when I change this, the controls I have for each light change as well. So each light is a little bit different in the way that it works. Now with the point light, the first parameter that you'll come across is this color picker. And this basically just allows us to change the color of the light. And you can see that here in the camera perspective window. I can make my lights really any color I want. I'm going to go ahead and leave it at the default of white. Now, right below that, we have an energy variable, and that is basically my light dimmer. It makes the light brighter or dimmer. So if I bring it up, make it a larger number, say let's make it about 3, and I do a quick render, you'll see that I have too much light in this scene, and it's blowing out the highlights. And this is actually a very common thing that you'll run across when lighting a scene, is that you'll have too much light in the scene. So it's always best to pay careful attention to this energy variable. And if you have too much light in the scene, you can always turn the light down. So if I bring it down, say below 1, and do a quick render, you can see how, again, the scene is getting a little bit dimmer because I have less light. Now, one reason why you'll have too much light in the scene is because you have more than one light. So always pay attention to that energy value. I'm going to return this to 1. And let's go through the rest of these. The next one is a negative light, and this basically just allows the light to subtract light out of the scene. So if you had too much light in the scene, you could either turn down the energy, or you could turn on a negative light, which would suck out that much light out of the scene. So if this was a negative light with an energy of 1, it would basically counterbalance that much light in the scene. So this is kind of great for fine-tuning your lighting. Now below this, we have specular and diffuse, and these are actually pretty important. And this allows us to separate out the specular and diffuse channels in the light. We can turn it on and off. Now notice how in this render we have a little specular highlights around the rim of the cup and the rim of the handle. Now if I turn off diffuse here and just render the specular, you'll see what I mean. These are the specular areas. This is where my specular highlights are showing up. So if I want to, I can just render those. And this is really nice for anything where you're going to do compositing later and you want a separate render channel. Another cool way to use it is to have multiple lights. One illuminates specularity, the second illuminates diffuse, and you can mix and match and have separate lights that make the specularity pop or whatever. So if I turn off specularity and just render diffuse, you'll see that, well, I get a pretty basic scene, but there's no highlights. It's pretty flat. So I'm going to go ahead and leave both of those on. Now, if we circle all the way back around to our fall off, we had it set to constant, but we have a number of other options. We have inverse linear, which is basically a straight line fall off. It's not quite inverse square, but it gives you a bit of a fall off for your lights. We also have inverse square, which we talked about, which is realistic lighting. We also have custom curves, which allow you to fall the light off however you want. And we also have a weighted light, which again is more of a custom setting. I'm going to go ahead and return this to inverse square. And let's again do a test render. But before I do that, let's go ahead and turn up the energy. Remember, this light is falling off with distance. So in order to get something a little bit brighter, we need to turn up the energy. So I'm going to go ahead and turn this up to 8 and do a quick render. And when I do that, you can see how now that light actually does illuminate the scene. In fact, it seems to be over illuminating it just a bit. So we can certainly turn that down. Let's turn that down to about 5 here. And again, just do a quick render. And you can see how when you have a fall off set, your lights are going to have to be brighter to illuminate something than they would with a constant fall off. Now also notice when this energy goes up, your preview changes. Now this preview is kind of set for constant value lighting. It doesn't calculate fall off, so you're not going to get accurate representation in your viewports. The last value we have is this distance value. So if I dial this down, you'll see that there's actually a sphere that surrounds your light. And when we click that sphere on, we can see the maximum distance that this light can fall. So this is actually kind of nice. If you have a light that's maybe illuminating something it shouldn't, you can actually turn on this sphere to look at the distance to make sure that you're not illuminating something you shouldn't. It's a great way to limit the effect of lights in the scene. So if I turn that on and render this, you'll see that it actually darkens the scene again, because what happens with this distance is at this line, the light is at half its intensity. So that's kind of your sphere of influence for that light. So those are some of the basics of how to use the point light. Now remember, the point light extends light in all directions, and you can have multiple types of fall off as well as many different types of color. In the real world, lights actually cast shadows, areas where the light is blocked. Now, in a 3D program, you can turn shadows on and off, and we have multiple types of shadows. So let's take a look at ray trace shadows in Blender. Now, I have this basic scene set up, which is our point light shining on a cup and a saucer. And let's just do a quick render of that scene. So as you can see, we get shading on the side of the cup, but the scene doesn't look realistic because there's no shadow. And we can add that in very simply. Now this is a point light, so we have an option for no shadow or ray traced shadows. Let's go ahead and turn this on. But when you turn on shadows, you do need to make sure they're turned on in the renderer as well. So I'm going to introduce you to this panel here, which looks like a little camera, and that's our render panel. And if we scroll down here, you'll see under shading, we have a number of options. One is, do we want to see textures? Another is, do we want to see ray tracing? And that's things like the reflections in the table. And because we're using ray trace shadows, we need to make sure that this is turned on. And obviously, we also need to make sure that the shadows option is turned on as well. So once we have ray tracing and shadows turned on, we can go ahead and do a quick render. Now notice how as soon as we turn on shadows, the render time slows down just a little bit, and that's because shadows do take time to render. But we do have a very defined shadow here. Now it's pretty black and it's kind of hard edged, but we can change that as well. But we are getting shadows in the scene. Now, if you don't want actual black shadows, there's a number of ways to get rid of them. One is to add more ambient light in the scene, but another easy way is just to change the color of the shadow. And this color picker allows you to do that. So I'm going to go ahead and just change the color of the shadow to a dark gray instead of black. And let's just do a quick render. So as you can see, even a dark gray shadow adds a little bit more realism. We can actually see into the shadows. They're not completely black and opaque. We can actually see what's beyond that shadow. And so that actually adds a little bit of realism. If we want to, we don't have to have just gray shadows. We can certainly make them a different color. So if I wanted to make a dark blue shadow, I could do that as well. Now, in this scene, a dark blue shadow might not be the exact thing we want, but if we had something that was semi-transparent or something like that, that might work very well. So I'm going to go ahead and make sure I turn off my saturation here and just make it into a dark shadow. Now, this shadow that we have is very hard edged. You can see here we've got a very crisp edge to that shadow, and sometimes we want that, but there are times where we don't want a hard edged shadow. We want something that's a little bit fuzzier. We can change that under the sampling option. One is the number of samples. So when we ray trace, we fire rays of light towards the object, and that will give us our shadow. So with only one ray, we're going to get that sharp edge. So what we need to do is bring this up. So I'm going to bring it up to 8. But we also need to affect this value here for soft. And so we want to bring that up a bit. So let's bring it up to about 1.5 or so. And now with 8 samples and a soft value of 1.5, you'll see that we're actually going to get a softer edge on this shadow. So one thing you'll notice is that with more samples, you have longer render time. So you have to kind of balance quality against the number of samples. In this case, I'm looking at the shadow and it's a little mottled. It's not quite smooth enough. So I'm going to actually bring up my samples to say 16, which again will increase my render time, but it should give me a more accurate result. So with 16 samples, you see you get a much softer edge with a little less graininess. So higher samples increase render time, but also increase the quality of the soft shadows. The spot lamp is probably the next most popular lamp in Blender, and it allows you to confine light to a very specific beam of light. Think about it like a spotlight in a theater where it highlights a certain area. A flashlight or car headlight would be another good example of this type of light. Now we can add these in under the Add menu and go under Lamp, Spot. And when I bring it brings in basically this lamp, and you can see that it has this cone of light that we can work with. Now, if I turn on texturing in my camera viewport, I can see how this works. So if I move my light up, you'll see how we get this kind of pool of light over the cup. And that's because we're confining the light to this cone. Now, if I were to move this back and forth along the y-axis, you can see how this pool of light moves with the actual light. So as this cone moves off the cup, the light moves off as well. But I can also rotate this into position here. And you can see now we have this light on the cup. Now, when we go into our light tab here, it looks like a little spotlight. You'll see that under this, we have a lot of the same controls we had for the point light. We have color, specular diffuse. We also have fall off. And I'm going to go ahead and set my fall off to constant. We also have a number of different types of shadows. We actually have what's called a buffer shadow, which we'll get to in a little bit, but I'm going to turn on ray shadows. And let's just go ahead and do a quick render of this light. So the render shows that we actually have a cone of light that's illuminating our object. I'm going to go ahead and size down this shadow rollout, and you'll see we have an option here called Spot Shape. The first one is the size of the beam. So is this going to be narrow? In fact, let's go ahead and see this in solid view here. Is this going to be narrow, or is it going to be wide? So if I make it more narrow, if we render that here, we could actually render just part of that cup. Okay, so I've got this really focused down. Or we can make it a little bit wider. We also have a blend option, and this controls the sharpness of the edge. So if I bring this out so it's just above the cup here, and turn this all the way to 0 and render, you'll see that this pool of light has a very, very hard edge. This blend option allows you to change that from hard edge to soft edge. So if I bring it way up, you can see how we have this inner value here. So if I bring this up to say 0.75, you'll see when I render it, it goes from a very sharp to a very soft edge. So this is really just the softness of the edge of that cone. Now typically the default's about 0.15, but we can make it whatever we want. We also have the option of making this a square instead of a circle. So if I were to render this as a square, you can see how this turns from a circular beam of light to a square beam of light. Think of it as having barn doors on your light. We also have an option here called Show Cone. And this is actually kind of nice because it allows you to see exactly what the light is illuminating. And this is really just for visualization of where the light is falling. So if I were to render this, it would render pretty much the same as we had here. But if we want to, we can turn on what's called a halo. And that's actually kind of a volumetric render effect. So if I were to render this with a halo, you can see how you can actually see that beam of light. Now, the actual intensity of this halo is controlled here. So if I dial it down, I get less of an effect or more. So those are some of the basics of spot lamps, a more controlled lamp that allow you to place light exactly where you want. When you use spot lamps, you have an additional type of shadow that you can use, and that's called the buffer shadow. Now, these are shadows that are created using a bitmap rather than ray tracing, and they can render much more quickly. So if you're using spot lamps, it's a good idea to take a look at buffer shadows to see if they'll work for you. Now, I have a simple scene here with a spot lamp shining on a cup, and this is a scene we used in the last lesson. And let's go ahead and select the lamp and change the shadow from ray shadow to buffer shadow. Now we have a number of options with buffer shadow. The first one is the color of the shadow, which is pretty much the same as you have for the ray shadow. And then down here we have controls for this specific type of shadow. And we have a couple of different buffer types as well as controls for those buffer types. Now we're going to take a look first at Classic H, which is probably the one you're going to use most. It's actually an update of the classical one. It actually works a little bit better. So under this, we have, first of all, filter type. And this is basically how does it blur the shadow. We're just going to leave this on box. And then down here, we have a softness control, a size control, in other words, the size of the bitmap it uses to calculate the shadow, a bias control. Now this controls how the shadow aligns with the object. Remember, this is a bitmap that is overlaid on the image. So this controls how that works. And then the number of samples. Now this is the number of samples to create a soft shadow. So let's go ahead and just do a quick render here to see what the defaults give us. And as you can see, it's a very workable shadow. So let's take a look at some of these controls. Now the first one is called soft. And let's go ahead and just dial that down to 0 and render. And as predicted, we get a very hard edge shadow because soft is at 0 and not soft is hard. So if we want, we can dial up the number of samples and that can make the shadow even crisper. Now, this size here is just the size of that bitmap that it calculates. If you get too big, you're going to have more bitmap than you have image. So large numbers really kind of give you a diminishing return. After a certain size, they don't really have much effect. But you can see when I turn it up to 2048, I get a much crisper shadow. That's because at 512, I'm actually undersampling in relation to the image. So you can see how I'm getting a much crisper shadow here. Now I'm going to turn that back down to 512. And let's go ahead and turn softness all the way up. I'm going to turn it up to a very high number. Originally it was at 3, but I'm going to bring it up to 32. And this will actually show you how it calculates this shadow. So with a very high value for soft, it shows you how it calculates the sample. You can see we have a bunch of different samples of this shadow from different angles. It moves the light around to give you different shadows, and then it blends those together. But the larger this soft value, the further it moves the light. And so you get this multi-shadow effect if you have not enough samples. And that brings us down to this. This is actually the number of samples we're using. How many times do we move that light? So at 3, with a soft value of 32, you notice you're not going to get a really good-looking shadow. But we can certainly bring that up. So let's bring that up to, say, 10, and then do a render. Now, with more samples, that means it moves the light more times and it has more sub-shadows to blend together to make this soft shadow. And notice how this shadow looks soft and it looks really nice. And more importantly, it renders a lot faster than a ray trace shadow. Now I'm going to bring my samples back down to 3 here. And I'm going to bring my soft value back down to 4. And then I'm going to do a quick render here. Now we're using the classical H buffer type. Now one of the reasons we use the classical H buffer type is because it's a new algorithm that Blender instituted back in 2.4 or so. And what it does is it prevents objects from self-shadowing and actually corrects some errors in the original algorithm. So with these values, if I go into a classical buffer type, you'll actually see some of the errors that we can get. So because of the specific values I have, we actually have a little bit of an error here in that we have a white spot in our shadow. And that's what can happen when you use this classical buffer type. So I tend to always keep it on classical H. Now, if you want, we do have some additional buffer types. We have what's called a deep buffer type. Now, this has all the same controls as classical and classical H, but it has a compression value for the shadow. And what that does is it gives you more bit depth in the shadow area, so that way you can get more image in that shadow. This is really better if you render at higher bit depths. Now, the last one is called irregular shadows, and that's really just a very simple basic shadow. And it basically just renders a simple shadow like this. And we only have one control, which is for bias. And so a higher bias value, say such as 3, will give you a slightly different result. In other words, the bias basically just moves the shadow. Notice how the shadow moved a little bit forward here. So I tend to keep my shadows on classical H. Classic H is probably the best general purpose algorithm to use. But remember, buffer shadows are based on a bitmap, which means they render faster, particularly for soft shadows. When lighting a scene, there are times when you'll need an overall general light, such as light coming from a specific direction. This is where we use the Hemilamp, which just creates directional light. So we're going to go ahead and add in a lamp called a Hemi. When we bring it in, you can see how it looks kind of like a hemisphere. And basically this light is a infinite hemisphere that projects light. So it's kind of like a spotlight in that the light is directional, but it doesn't have a specific source. So it doesn't create a cone such as a spotlight. If we go into the properties panel for this, you can see that the Hemilight has very few controls. We have a control for color and energy, specular and diffuse, and that's about it. The Hemi-Light does not cast shadows, but it does have direction. So if I were to bring this directly above that cup and just do a quick render, you can see that we get a general light from above that cup. You can probably see this a little bit more if I point the light in a specific direction. So if I were to point this light completely to one side, such as this, then if I render, you can see that I'm getting light coming from the back of the cup. So if there was a light coming from here, you can see I get shadows here and here. And we can do the same on the other side. So if I were to point the light that way, you can see how I'm getting light coming from this direction on the cup as well. Now, one of the things about this light is that it's not location specific. So even though I have this icon here floating in space, it doesn't mean that that's where the light is originating. Again, the light originates from infinity. So it doesn't really matter where this is. This just controls the direction of the light, not the position. So if I were to even keep this light above the cup and point it straight up, I should get a nice underlighting effect. Okay, so as you can see, this light can be very useful in creating directional light. Its only control really is the direction of the light and the color. There is no position of the light, there are no shadows, but you can use it for a nice general illumination. Blender's area lamp provides light from a specific region rather than a point or a source. So let's take a look at how to use this. I'm going to add in an area lamp. And when you bring it in, if we zoom in, you'll notice that it's a square. And this is where the light is originating. So we're actually projecting light from this square. This is really great for something like a softbox or a window that's generating light, because when you combine this with shadows, it actually can create some interesting effects. But let's just look at the basics of how to use this. I'm going to click on the Area Light tab in my Properties panel. And you'll notice that, just like with most lights, we have a color, energy. We also have distance and gamma. Gamma is actually contrast. But distance is actually very important. Let's go ahead and position this light. I'm going to go ahead and move it up and move it over. And I'm going to rotate it into place. So I'm going to go ahead and rotate it just like I did with that spotlight so that it's just pointing at the cup. So let's do a quick render, see what this looks like. Well, this is awfully blown out. And that's because the area light doesn't have any sort of fall off except for this distance control. And if we zoom out, you can see that this light has a dotted line, and the end of that line is where this distance is. So this is typically where that light is evenly illuminating the scene. So we have a choice. We can move the light back or reduce the distance. Probably easier to reduce the distance, so let's go ahead and do that. I'm going to drag this distance down and bring it up so that it's just touching the top of the geometry there. So somewhere around there. In this case, I have it around 7 or so. And now let's go ahead and do a render. So when we do the render, you can see how the exposure of that scene is much better. But we can continue to control how this light works. If we scroll down here, you'll see that we have an area shape. So if I take a look at this area light here, you see right now it's a square. We can change the size of this square, or if we want, we can turn it into a rectangle. Now, by itself, this shape doesn't have that much of an effect. So if I were to make this, for example, a long rectangle, you would think that, okay, this is going to be like a tube light or something like that. But when I actually do the render, you'll see that, well, it looks pretty much the same. But where this really takes effect is when you have shadows. So let's go ahead and turn this back to a square and bring it back down to the default size of 1. And let's go ahead and open up shadows, and you'll see that area lights have a ray shadow option. And just like with all ray shadows, we can actually give it a color, and then we have a number of different types of samples. So let's go ahead and leave this at the default and just do a quick render. Now, with the samples at 1, you'll see that the render has a very hard edge, and this is typical for most ray trace shadows. That's because we're only casting one ray of light, and so we are going to get a sharper shadow. But if we bring the number of samples up, say to 4, and go ahead and do another render, you'll see that the shadow gets a little bit softer. So as you can see, with more samples, we're getting a softer shadow. That's because we have an area from which to project those samples, or in other words, rays of light. And this is where the size of your area light comes into play. If we make the size smaller, let's go ahead and bring it down to say 0.25 and keep everything else the same, when we render, we're going to get a much sharper shadow. So as you can see, with a smaller light, we get sharper shadows. That's because the sample rays are coming from a smaller area. So conversely, if we bring this up to say 5 and make it a really big light, you're going to get much softer shadows. So with a bigger light, I get much softer shadows. But also notice the bigger light creates a much grainier shadow, and that's because we don't have enough samples to cover a light of that area. So if we are going to use bigger lights, then we are going to need more samples. So I'm going to bring this up to 16 and then do another render. So as you can see, with more samples, the render becomes a lot smoother. Now, one of the things you'll notice with area lights is that they're very render intensive. It takes a long time to render with area lights. So if you can get soft shadows or the same effects using different types of lighting that are more efficient, please go ahead and use them. When you start rendering scenes, there are many times when you'll need a background to go behind your objects. Take a look at this house, for example. We have basically a black background behind the house, and this is the Blender default. Now, typically, if the house isn't being shot at night, you'd want to see something like a sky or something behind that house that isn't black. Well, we can change this by using the world settings within Blender. So all we have to do is go over here to this little panel here that looks like a planet Earth and click on it, and you'll see that it's the world panel. Now in here, we have a number of controls to add color and gradients to our background. Now the first one you want to take a look at is the horizon color. If I click on this, it brings up a color picker. And so let's say I wanted to have a blue sky background. So all I have to do is find the blue that I like and click OK. So once I have that, I can hit a render, and you'll see that this horizon color is now my background color. Now if I want, I can go even further. We have two additional colors. One is zenith color, the other is ambient color. Zenith color allows you to create a ramp. So if I click on the middle option here, which is called Blend Sky, you can see that this zenith color becomes active, and by default it's black, so we go from black to blue. But we can change it to whatever we want. So let's go ahead and make a sunset. So I'm going to go ahead and change my horizon color to kind of a yellow here. A yellow-orange, like it's being sunset. And let's change our zenith color to a darker purple. And so now that I have this, you can see I have this gradient. So when I hit render, you'll see that that gradient shows up. Now in this case, it maps this gradient here to a virtual sphere around your scene. So you may not get that purple at the very top, and you may not get the yellow at the very bottom. That's because it's mapping it more to the world than to my actual image. If I want to map this exactly to my frame, all I have to do is click Paper Sky. Notice how it changes a little bit here. And when I render again by hitting F12, you can see how the top of that image is my zenith color, and towards the bottom, it's my horizon color. So that's the way to fit that gradient exactly to your screen. Now, we have another option here called Real Sky. And if I click on this, you'll notice that I get sky on the top and on the bottom, and then in the middle, I get this horizon color. And what this does is it creates an actual sky where the horizon is at the horizon in the scene. So if I were to do a render of that, you'll see that I get kind of a yellow band through the middle. So if you use real sky, you have to have your camera placement exact so that way this horizon matches up with the horizon in your scene. So I'm going to go ahead and click that off. Now the last option we have here is called ambient color. And this really just controls the overall base light in the scene. So this is basically the darkest you can ever go in a scene. By default, it's black, and you can really see it here in the shadows. I have basically just one light here in the scene, and it's creating a very dark shadow here. Now, if I wanted to, I could actually change the color of that shadow in the light. But if I want to create an overall ambient light, I can do it here. So if I click on this ambient color and just bring it up to a 30 or 40% gray here, and let's go ahead and render, you can see how everything in that scene is grayed out. So the darkest color is this color. So typically you want to keep this fairly low, maybe slightly above black so that we don't get exact pure black, but we get stuff that's fairly dark. And so something like this is probably a little more realistic. But again, you can use this very creatively. If you want to tint an entire scene, you can do that with the ambient color. So to refresh, the horizon color and the zenith color both create a ramp for your background. Horizon color alone will just create a single color. If you want to match your sky to your frame, then be sure to use Paper Sky. Many times you'll want to use something other than a gradient for your background. Often we'll use a bitmap of a sky or something like that to create a background. So let's show you how to add a bitmap to your background. Now I have the scene I was working on before, and in my world I have this gradient set up. So let's do a quick render to see what we have. So we have this set up to Paper Sky and a blend sky with this horizon and zenith color. Now, if you want to add a background image, it's very similar to working with materials. All you have to do is keep the world selected and then go immediately over to the texture panel. And when we do that, we can add in a new texture. It understands that you came over from the world panel here. So we go from texture, world, or both. So with the default clouds, you can see it's overlaying the clouds over that gradient. But in this case, I really don't want to use a procedural texture. I want to use a bitmap. So I'm going to go select image or movie. And then under the open tab here, we're going to select sky, open image. And you'll see I have a blue sky with white clouds. And what it's doing right now is overlaying that over the gradient. So let's scroll down and see how we can adjust this. So I'm going to close off a bunch of my rollouts and go to the influence rollout here. And the most important one here is this blend control. And what this does is it blends in the bitmap over the gradient. Now if I turn that off, you'll see that I have just the gradient and this has the blend. Now we have a couple of blend options here. We can have add, subtract, overlay, all sorts of different ones, darken, saturation, and so on. And some of these may work, some of these may not, but I'm going to keep this at mix for the moment. And what we're going to do is we're going to blend in the bitmap here using these ones along the bottom. So I'm going to click on horizon, and then I'm going to turn down blend here all the way off. So basically, we're not blending anything. We're just replacing the horizon color, which was yellow, with the sky bitmap. So once I do that, you'll see that I get sky at the horizon, and then it still fades up to the zenith color, which is that purple color. Now, if I want, I can replace the entire gradient with the bitmap just by clicking on that zenith color. And I can now have a complete bitmap sky with none of that gradient behind it. And now if I want, I can mix in the horizon color. Let's say I did want kind of a yellowish horizon. I can still do that just by bringing this slider down. And so I can still have that horizon color. So those are some of the basics of adding a bitmap as your background image. Now remember, just start on the World tab and then go immediately to the Texture tab and add in whichever texture you want. Now let's take a look at the last lamp in Blender, and that's the sun lamp. And this creates a good approximation of sun, and it can also add in sky as well. So let's go ahead and add in a lamp sun. Now, the sun lamp basically works the same as a hemi lamp in that it is directional and not positional. So, really, the only thing that matters is the direction of the light. So, I can basically keep this light here at the origin where it came in, or if I want, I can move it anywhere I want in the scene. Now, I'm going to move it a little bit up here so we can just see it. But the direction of the light is really all that matters. So, if I render this as is, you'll get light from above. In other words, you'll get pretty much noon sky. Now, if I want to, I can rotate this. So if I rotate it this way, then you can see how the light now comes from the front of the building. So if I change this to local and I angle this a little bit more, you can see how, again, I can get light from the side. One of the big differences between the sun lamp and the hemi lamp is that the sun lamp allows you to do shadows. So if I go down to the very bottom here, you'll see I have a shadow rollout, and I can cast a ray shadow. And the parameters for this are pretty much the same as for the point light. So I won't go into those, but let's just go ahead and see that we can cast a shadow with this light. Now, probably the most interesting feature with this light is the sky and atmosphere controls. And these allow the light to create an artificial sky as well as an artificial sun. So I'm going to go ahead and turn this on. And as you can see, it creates a horizon with a sky. And if we render this, you'll see that my sky gets replaced by this particular sky. Now, we have a number of options here for controlling this effect. But if you want, an easier place to start are with a couple of standard presets we have. We have a classic sky, we have a desert sky, and we have a mountain sky. Now, the only difference between these is that it just changes the settings to reflect the preset. So once we dial in, say, a mountain sky, we can still continue to tweak the effect. So let's take a look at what this looks like in render. And so you can see it basically just has a gradient, but we don't have the sun visible in the sky. Well, that's because the sun is actually behind the camera. Now, if you look in this scene, you can see that the camera is here facing at about a 30-degree angle towards the house. Now, in order to see the sun, we have to actually point the sun at the camera. So I'm just going to go ahead and change the angle of my sun so that it's pointing pretty much towards that camera. And you can kind of see it here in this viewport. So when I change the angle so that it points at the camera, you can see how now I can see that sun in the sky. In fact, if I angle up just a hair here, it might actually come in a little bit lower in the sky so you can see it. Now, you may think that because the sun is here in the viewport, that's where it is here in the render. But that's not really the case. Again, the sun is not positional, it's just angular. So it really depends on the angle in relation to the camera. So even if I move the sun completely out of the frame here in the perspective viewport, I would still get the same render. Remember, it's really the angle in relation to that camera. So now that we can actually see the sun in our render, let's go ahead and start playing with some of these parameters. Now, one of the first ones is blending. This is how it blends to the original background. And again, we have all of our blending controls here, but the one that's most important is factor. If I dial this down to 0, I get the original background. If I dial it up, then I start to get the sun. Okay, and typically this is at 1, which basically just completely replaces that blend sky with my sun. Now I can also create a brightness for my horizon. So how bright is it down here? And again, that shows up very nicely in that render. Or if I want, I can turn my brightness down to 0 to have a not bright horizon. The other important one is the sun controls. How bright is this sun? So we can certainly make the sun brighter, and so that will definitely show up in my render. I can make it dimmer. I can also change the size of the sun. So a smaller sun with the same brightness will make the actual ball of the sun smaller, but the brightness will stay the same. So if I make my sun bigger, you'll notice that it actually looks a little bit bigger in relation to that. Again, I can see my sun a little bit better. These parameters can really be tweaked as much as you want. I would suggest starting with one of the presets and working from there. Now, the final control here is atmosphere. So again, do you want to add in atmosphere to your render? And that basically just gives you kind of a fog effect here. So as I add in atmosphere, I can start to see how much atmosphere I have in terms of how much does the sun affect it, as well as what's the distance of that atmosphere. So again, the higher the distance, the more atmosphere I have, the lower, the less effect I have. So you can create a hazy morning effect, again, just by adding in a little bit of intensity here and not too much. So those are some of the parameters that you can use with the sun lamp. And you can see this is a very, very versatile tool that you can use to create realistic skies. Another popular form of lighting in Blender is called ambient occlusion. Now, this is very similar to ambient lighting, but it adds in additional shading that gives it a much more realistic effect. So let's take a look at this scene. I have my standard cup and saucer, but I've removed all the textures so you can see the effect more clearly. Now let's go ahead and render this scene. And as you can see, there are no lights in the scene. Now, ambient occlusion does not need a light to work. It's kind of like ambient lighting in that it's just an overall lighting in the scene. It's not a specific light. So we can get to ambient occlusion by going into our world panel and scrolling down to ambient occlusion. When I click that on, you'll notice how two panels light up, ambient occlusion and gather. Let's just go ahead and do a quick render of ambient occlusion. Now, as you can see, we get shading in the scene. That's because we're creating an overall ambient light. Now, ambient occlusion can be controlled. So we have a factor here, which is basically how much ambient lighting are we adding into this scene. We can either add or multiply against the existing background. So if we turn this down, say at a 0.24, 0.25 or so, and do a quick render, you'll see that the overall ambient lighting has been reduced. And this is great if you're going to be using this in conjunction with other lights so that you can have another light actually doing the specular and the diffuse, but you still have an overall ambient lighting in the scene. I'm going to go ahead and turn this up to 1 again. Now, the color of the ambience is based on the ambient color in the world settings. So right now it's black. So my darkest ambient color is going to be black. I can change this to any color I want. Usually we can change it to something like a dark gray to give it just a little bit of a brighter effect. Or if we want, we can tint this by adding in a color. So if I wanted to, for example, make this a green color, I could. And you'll see that now my overall ambient lighting is green. I'm going to go ahead and turn that back down to a dark gray, something like that. And then let's just do one more render. Now, another way to control how this effect looks is to go down to the Gather tab. By default, it's set to ray trace, and so it uses ray tracing to create that overall ambient effect. Now, ray tracing can be expensive in terms of render time. So we have a number of samples here that can control how much ray tracing it uses. So with a default sample of 5, you can see how in this particular image, we still get a little bit of graininess. But if we want to, we can turn that up. Let's say we bring it up to 10. We can render that again. And you can see how with more samples, it smooths out the graininess. But it also adds render time. So you have to find a balance between acceptable graininess and the render time. So if we want, we can also do another type of gathering, and that's called approximate. And what this does is it just approximates the ambient occlusion effect, and sometimes this may just be good enough. if we do a render with the default settings here, you'll find that in this particular scene, we get kind of a harsh effect. You'll see that the dark areas are very dark and the light areas are very light. But we can smooth that out by using sampling. So if I bring up my sampling passes just to 1, you'll see that this smooths out very nicely. But again, the more passes you have, the more render time. But overall, approximate gather is actually a little bit faster than ray tracing at the expense of accuracy. Now I'm going to go ahead back to ray trace and turn my samples down to 5. Now we have another way of doing ambient occlusion, and that's using what's called environment lighting. Now if I switch off ambient occlusion and turn on environment lighting, if I render that, you'll see I get pretty much the same effect because really environment lighting is just another form of ambient occlusion. Now, environment lighting pulls its color not from the ambient color here, but from a selection that we have. By default, it's at white, but we can use the sky color or the sky texture. So if I change this to sky color, I can turn on my blend sky here and give it a horizon color, let's say a dark blue, and a zenith color, let's say a very pale blue. And what we can do now is use that to create my ambient occlusion. So when I hit render on this, the dark areas will be my horizon color, the light areas will be my zenith color. So you can see I get an overall tint of the scene. Now, if I wanted to change this a lot, I could, for example, change my zenith color to a yellow or something like that, and then again render, and you can see how it goes from yellow to blue. Now, another way to do this is with a sky texture. Now, we did this before in a previous lesson, but if we want to, we can go over to the texture panel and add in a new texture. By default, it's set to clouds, but let's go ahead and pull in an image. And we're going to pull in that same sky background that we used in the previous lesson. Now, in order for this to show through, we need to change our influence. So I'm going to go ahead and turn my blend down to 0 and turn on horizon and zenith. And this will go ahead and make this bitmap show up as the background. Now, if I go back to my world settings and make sure this is set to paper sky, I can use this to create my ambient lighting. So if I turn this environment lighting on to sky texture, it will now derive my environmental lighting from this bitmap texture. So if I hit render, you'll see how this works. So with that render complete, you can see how it's pulling the colors from my sky. This is a great way to get very realistic lighting. You create a sky texture, turn on environment lighting, and then you can balance this using the energy in the scene against the real lighting. So just to refresh, ambient occlusion creates a overall ambient lighting. And we have two forms. We have ambient occlusion, which is just a simple color, or if we want to have more complex lighting, we can use environment lighting.